Hi, Johnny. I'm going to tell you about 420. No, not that 420. This 420. When the clock says 420, it looks like this. The minute hand is pointing at the 4, but the hour hand is not. And of course it isn't. When the hour hand was pointing at the 4, the minute hand was pointing at the 12. Which brings us to the topic of this video. At what times do the hour hand and the minute hand point to the exact same place? Well, with the exception of midnight and noon, it's not on the hour. Obviously, it can't be every hour on the hour, because every hour on the hour, the midnight hand is pointing at 12, and the hour hand is pointing somewhere else. 2. It has to happen regularly. The hour hand and the minute hand move with constant velocities. It takes the minute hand a certain amount of time to catch up with the hour hand, and it takes the same amount of time for it to catch up again, and again, and again. In other words, the point at which the eclipses take place are evenly spaced on the clock, and evenly spaced in time. 3. The time interval between eclipses has to be a divisor of 12 hours. We know that an eclipse occurs at midnight. We also know that an eclipse occurs at noon. Because we know that the eclipses occur at regular intervals, it has to be the case that some number of eclipses add up to 12 hours. So, for example, maybe exactly 9 eclipses add up to 12 hours, maybe 10 eclipses add up to 12 hours, etc. In other words, the interval between eclipses has to be some number of the form I equals 12 hours divided by n, where n is a natural number. Now, we know n cannot equal 12, because then our interval would be 1 hour, and that's impossible, because an eclipse occurs at midnight, and 1 hour later it's 1 o'clock, at which point an eclipse definitely does not occur. Here's a simple way of working it out. In a given 12-hour period, the hour hand goes around once, and the minute hand goes around 12 times. That means the minute hand crosses the hour hand 11 times, and eclipses it on each of those 11 occasions. We know that the eclipses are evenly spaced. We also know that you can fit n of them into 12 hours. Well, that means that n must equal 11, which means our interval is 12/11ths of an hour. That's 65 minutes, 27 seconds, and 3/11ths of a second, which is 5 minutes, 27 seconds, and 3/11ths of a second longer than an hour. So the eclipses happen at these times, and on these points. I hope that was educational for you, and I'll see you tomorrow.